Our sponsor is SAIC. They work closely with the Rapid Capabilities and Critical Technologies Office, otherwise known as RICTO, who work to serve and find rapid prototype solutions to solve Army and government problems. One of these issues involves the validation of radar systems, such as counter-UAS systems.
So, counter-unmanned aircraft systems, or CUAS testing, requires precise validation, and military programs rely on accurate data to evaluate radar performance. However, existing solutions have high production and replacement costs. They pose potential security risks due to being manufactured by foreign companies and are susceptible to destruction during testing, which leads to frequent replacements.
One of these existing solutions is the use of truth pods. These are specialized devices designed to collect and transmit locational data during testing events. These pods serve as a ground truth reference, helping verify the effectiveness of radar and directed energy systems. As mentioned earlier, these existing solutions are expensive to produce and replace and rely on foreign manufacturers and are prone to destruction.
So we attempted to solve this issue by implementing our own truth pod solution for our sponsors to use during their validation tests. Our solution aims to be cheaper to produce and be composed from parts from domestic manufacturers. So you can see here is our overall use case diagram. These yellow pucks represent our truth pods. These are white drones that represent a UAS, and down here would be our base station that is receiving data from our pods attached to these systems so that they can be compared with data from a radar.
So here are the overall specifications of our solution. Each truth pod is comprised of an Adafruit Feather RP2040 with an RFM 95 LoRa radio. That's the module here on the left. In the middle, we have an Adafruit Ultimate GPS Featherwing module for collecting our GPS data. And finally, on the right, we have an Adalogger Featherwing Micro SD module for use in local logging our data on each pod. Here is the truth pod package fully assembled. Each hat stacks on top of each other to keep a truth pod in a small package. Each pod is smaller in dimension than 2.5 by 1.5 by 2 inches and weighs less than 200 grams, and each pod costs less than $100. They're each capable of keeping locally logged data, and they each send their GPS data to a base station unit that would be hooked up on the ground to a desktop or laptop computer.
So there's our truth pod on the drone.
Oh yeah, that's good.
Yeah, they got it.
All right, so we just propped the drone up. We have clear line of sight, and we're getting logged information currently. We have GPS data, time, altitude.
So this data that we're plotting now is from a test we did with our sponsor where we went out to a field and flew a drone for about 20 minutes. So to the right, you could see this bar graph that is denoting the time from the start in seconds, and we could see kind of how the drone flew around. So we first started about right here in this dark purple kind of area. We had the drone flying for quite a while to make sure everything was right, and we flew it straight up, flew it around. I think to this endpoint is about 3K from the start, and then we flew it all the way back down. And this whole thing is about a 20-minute test. So we're pretty happy with the results, and we were able to represent track fairly well.